go first and talk about the simulation team? Yep, that's it. Sure, we're gonna get set up. Huh? Oh, he's got it.
And we're doing about 6 presentations, right? So for an hour, and then we go into the breakout.
We go into the breakout. We are kind of late, so the breakout's gonna be shorter than it would be. But oh, there's not six working groups. There's four, isn't there?
Well, no, but I was. So the thing is that it's not just one presentation per working group. There could be 2 presentations per working group.
Oh,
Because whoever wants to present something should do that. It's not just the leader.
got it. Who, if you're planning on presenting, raise your hand. Okay, so for these first set of presentations, only four, but then tomorrow it might be different, or this afternoon it might be different.
Have it, people will have some individual time to prepare the presentations if they want to. So after breakout, we'll have individual time. People will have time to, write something out, make a presentation, and do set next iteration.
Alexa, you're on point today. Thank you.
Well, I've been thinking about it for a long time. Almost 3 weeks.
Yeah, totally. All right, cool. We're just getting set up here. Who's not in the All Core Devs channel? Pretty much everyone here should be in the All Core Devs channel on Gitter. It should be gitter.im/Ethereum/all core devs, all one word. If you're not in there, join it. There's a lot of good discussion in there. That's where the core developers meet up for Ethereum, and if there's something major going on, we meet up in there. We announce meetings in there. If you're interested in coming to the meetings, if you feel you can contribute something, then let me know, and I can definitely help with that. You ready to go? All right. Thanks, everybody. Shahan.
It's pronounced Shahan, actually.
I'm so sorry.
That's okay. Very short presentation just to give everyone an intro into the simulation working group. The simulation working group started in Prague as part of the ETH WinX stuff. And the goal is to do some analysis that will help the community develop the roadmap. One of the first things to do is talk with people, find out what analyses people have done, and then start exploring ways to do those analyses. That requires collaboration, communication, openness, because we need data sets, we need code, we need different groups to coordinate what they're doing. So currently we're working on the main simulation that we're working on right now that's being run by Vanessa and Nicola is the uncle rate simulation. Basically, there was a question that came up in Prague about why are uncle rates dropping, what can we do to help understand what uncle rates represent on the mainnet, and how they impact clients and network protocols. Along the way, there are several steps: collect data sets, develop models, and also test plans to determine how these potential understandings are simulated and emulated, and share those results with the community. So we have a few data sets that we've collected. Alethio has provided us with some ETH stats. Thanks, Hudson, for sharing stats from ETH stats. Etherscan, those are the public charts that are available. And Zach will talk about the nodes on the network proposal, essentially launching nodes on the mainnet to collect some statistics from the live network. So there are two emulation frameworks being used and explored. Nicola and Vanessa are working on the Wittgenstein simulator, which you can model different consensus algorithms, and at the same time, because uncle rates are related to network protocols, it's being used for that as well. And Zach will be able to talk about the testing platform, which is essentially a platform that's being designed in order to reduce some of the overhead that goes into network protocol analysis, usually associated with, say, latency and low-level network access. So while there are a lot of simulations that deal with, say, just modeling or clients that you can launch on Amazon, the platform will enable people to do deeper dive into the network protocols. So the roadmap for the working group is collecting data, doing analyses, working on the code bases. One of our goals here this weekend is to figure out who else we can talk to, who else wants to get involved, and communicate with other working groups. Even though we're working on uncle rate simulations right now, we believe that the working group can help address other simulations and statistics or analyses that need to be done, state rent or state pruning. There are a lot of statistics analyses that have to be done, and we want to find a way to do that perhaps more generically with tools that can be reused rather than just each group having to do that. So kind of join forces and help each other. As well, some of the other areas that we're going to explore are gas costs, because things like state rent, all of these analytics deal with the cost of transacting on the network, and we need to better understand what impacts each of these components have on these things. So in the sidechain conferences, we'll review the analyses, we'll invite others to join, so if there are people from other working groups that are requesting data sets or things like that, please come talk to us. And that's my email. Any questions?
I suggest that what we do is that for this very short presentation, we take the questions online, but most questions should just come when you're like
Okay.
finished. But yes,
Sounds good.
because that allows people to just drift around and just talk to many.
Okay. Shall I invite the next group up? Shall I invite EWASM?
Sure. Who wants to go next?
I've heard from a couple people that the audio on the stream is pretty low, so I guess just make sure you speak into the mic. That's what you do. Yeah. Yes, sir. Yeah, you can increase the audio. Great, thanks.
Can someone help me with the computer? Is there a password? Or?
Oh, is this the computer which?
I put my slides on this computer.
Oh,
I think, I hope. My slides are somewhere else. Hello, we're excited to be here. I'm Paul, I'm on the EWASM team, and we have a list of our names up there. We have EWASM working group proposal that we released a document a few months ago, and I'm just going to speak very, very briefly today. Just an introduction and a reminder of what that was. First, two problems. The first problem. WebAssembly is great, but it's designed to execute arbitrary code at native speeds, but it's not designed for consensus, but it's pretty close. It's close enough that we think we can choose a subset of it that is designed for consensus, and that we can have guarantees of what's going to execute so we can avoid consensus bugs. And so that's the first problem. That WebAssembly is great, but it's not quite there with engines yet. We have to modify things. We have to choose subsets of it. The other problem is precompiles are a burden. We haven't had a precompile for a long time because implementing, auditing is done by each client, awkward gas metering, testing. Who's going to do all this work? So people are reluctant to keep on adding these precompiles. So the idea was one precompile called EWASM, and then that's going to be the last precompile. Then we can launch things on this EWASM precompile. And so these are the two problems. So the solution is replace the current precompile infrastructure with WebAssembly. And this is a first step in a journey for general user-deployed EWASM contracts. The advantage of precompiles is that we have a subset of EWASM. We can start with a first step, a small step, where we're sure we know what code we're executing. We can check things, and we can hopefully audit and even verify things before we even start. The deliverables are listed. I think there's some of it is being occluded. Okay, there it is. So we have, we're going to deliver WASM modules for existing precompiles and a bunch of other precompiles. The specifications for the interface and the implementation of these specifications are a lot of work. Geth client parity, all of these things take a lot of work. The specification is a lot of work. Gas metering is a big thing that we'll talk about. It's really interesting, actually, if we can find some way to automate metering of precompiles, and there are some options. And the goal of this first step is to have a streamlined process for deploying precompiles, where someone can give us a module and we can deploy it. And maybe eventually we'll let users deploy their own precompiles. Everything automated. So that's the ultimate goal, but we're taking a first step. We're just exploring ideas, and we're building experiments. Nothing is sort of finalized yet, so we're still open and we're still discussing, but this is sort of the state we're at right now, and there are discussions. Perhaps we'll just go straight to user-deployed EWASM contracts. Perhaps we'll start with precompiles, and there's a lot of other questions. We'll talk about it this week a lot, so really exciting stuff, and we hope to hear from everyone. So there are some discussion channels that we're available on. And that's it.
Who we got next? Okay. Head up, Alexi. Absolutely. We got the live stream up and we got 14 people watching.
Right, cool.
Ooh. How many are in the room? Yeah.
So, I don't know what's happening. Okay, so I'm not going to go straight into the, state rent yet. I think it makes sense to, gosh, no. I'm struggling with it. Sorry. Okay, so I think it makes sense to do a little introduction into, this is my point of view on Ethereum 1x, and of course a lot of people can object, but I think it's useful to explain what binds us together, why these are four groups they came up, not the others, and some of it is sort of accident and some of it is not. So let's look at the short prehistory, I would say, of how this whole thing came about from my point of view. Is that first of all, in Cancun in DEFCON 3, Vitalik had his talk about Modis' proposal for Ethereum 2.0, in which we sort of hear this proposition that that Ethereum, existing Ethereum 1.0 should stay safe and conservative, and all the kind of the break in innovation should go into the Ethereum 2.0 in the shards. So that included EWASM, and I think this is the first time when I heard that EWASM is probably going to be shifted towards 2.0 and other things as well. So we basically realizing that the current chain is too valuable to sort of do the break-in changes and so forth. And so people largely agreed with that sentiment. So what happened next is that, I mean, again, from my personal perspective, I was at Con and Vitalik was talking about, do you want to become Casper validator, which sort of signaled that Casper is very near. It was Casper FFG at that point, and people got really excited about it. And it was one thing in particular which was very exciting is that the slashing condition was changed so that if your equivocation, like if you're voting on the multiple blocks in the same height, and that sort of didn't cause too much trouble, then your slashing is going to be less. So that means that there will be less risk of participating in a validator pools. And then another thing I remember that essentially enabled people to validate from a laptop, which was really cool. So, but then June 2018, something changes. So one of the core dev meeting number 4, which I have a link there, but basically there was a pivot announced by the research team. So essentially, like, initial idea was to have Casper to have a contract on Ethereum 1.0, which would be validating the votes and doing other things. And the sharding was a different research group, and they realized that they're researching pretty much like very similar things, and they decided that it's going to be very challenging to validate all the votes on the contract simply because there was too many signatures to verify. And so the decision was made to join together the Casper and sharding research groups and not do contract-based Casper. And this is where we start hearing things like Beacon Chain and Shasper, which is the sort of the hybrid of Casper and sharding. And so then if we look at what happened in October, November, which actually the events which led to creation of this our Ethereum 1.x is that we came to Prague and we kind of realized that, well, this is going to take a bit more than we thought before. What I mean by this means that the Serenity, Ethereum 2.0, and so when I talk about this Serenity, I don't mean a Beacon Chain is going to be alive. It might be even alive at the end of this year, but actually to functionally supersede the Ethereum 1.0, it might take longer because a current plan is to do phase 1, phase 2, phase 3, and the phase 3 is, or maybe phase 2 they call it, if you count from 0, is where you have execution engine and everything starts working. And also, I think somebody says that, well, also then you need to go through the trial by fire, which means that survive a few attacks and things like this, and until people become comfortable using this chain. So we're talking about optimistically 3 years, pessimistically 5 years, maybe even more. So as I was joking to Vitalik, I will retire by then. So why did this whole start? So it is in Prague. When I came to Prague, there was a kind of sort of cognitive dissonance for me. Around the rooms, I saw lots of excited people who were building stuff on Ethereum. They were really kind of cheeringly excited. But I saw some different people who were kind of going around and thinking like, oh, the sync is taking too long. There's too much data to go around. The nodes take more and more space and stuff like this. And so there was a sort of, the people who I talked to, I started hearing the sentiment, and then eventually we just start talking to each other about this. And this is how the Ethereum 1.x came out. Again, this is my personal perspective. Please correct me if I'm wrong. But the main point of the Ethereum 1.x, from my point of view, is to develop and design some changes that we can make into the existing network so that it survives until the Ethereum 2.0 supersedes functionality and people do migrate. So which we don't know how long it's going to take, but the danger of not doing any changes is to basically we don't going to have any intermediate thing between 1.0 and 2.0. So there was, otherwise there's going to be some kind of rupture. And so another important thing, which I sort of started talking about, emphasizing that we're concentrating on solving this problem, because as we saw before, that the bandwidth of changes in the Ethereum protocol is really low. I mean, it takes months to figure out how and what we're going to change, and given that, we might not be able to afford to introduce more and more features which we kind of randomly collect along the way. we really need a focused attempt. And here, this is why I see EWASM as a part of this combination, is that it allows you to deploy the meta feature rather than the specific features. And I think for deliverables, again, could change as well. So, but out of the 3 working groups, so there's 2 things which definitely will require hard forks if they ever are going to be accepted. And storage pruning, at the moment, we're thinking about it might not require the hard forks, but it might if we find out there's something we have to do to make this whole thing better. It might actually require hard fork. And at the moment, we're thinking about emulation and simulation groups as a kind of way to help others to research things, but that's pretty much it. Yeah, so I think I'm not going to go over EWASM because this presentation contains a short information about all the groups, but I think I will just let other people to do that. So this is the end of my short presentation. I will do the statement in the next round, or maybe later this round. We'll see. Okay.
Thank you, Alexei. Next, we have EWASM, right? Or Fred. Wait, God. All right, Fred. Everyone, keep me on my toes.
All right. I don't really have a presentation. I'm just going to talk through Peter's proposal because this is originally Peter Shilagi's proposal on chain pruning, and I'm been involved in the discussion for a long time as well, so I think it's good to get a bit of history and sort of what chain pruning is all about. So we all know that a full node takes a lot of space. It takes about 140 gigs or so to run a full node, and it's not really reasonable expectation for someone to run it on their laptop anymore, and that's something that we want to address. And so this, has been a long discussion. Bitcoin introduced this a long time ago. Pruned nodes there are pretty common, and Rob is one of the main consensus developers at Parity. He had a talk at DevCon 3 in 2017 on basically trying to shard up the block history across multiple clients based on like the first byte in the key, in the node key, something like that. So basically breaking up the storage. That was met to pretty cold reception, I would say. It's been a discussion for a long time, but no one is really willing to take action. And now we're starting to really feel the pains because the number of clients in the network have reduced drastically over 2018. So I think we need to do something to encourage people running more clients, and this is one of those approaches. So just going over the proposal from Peter, he highlights that cross-client coordination here is important. This is like chain pruning is something that any client can implement today if they want to. It's not really that big of a problem, but if Parity implemented chain pruning by putting all the blocks on IPFS and Geth implemented it by putting it all on BitTorrent, then we can't really sync from each other anymore, and that's a bit of a problem. But furthermore, if then Trinity wants to join the network and they have neither of these methods to bring historic blocks, then they can't join the network anymore because they would need to implement one of these methods to even get history. So that's the thing. If every client pushed towards having this as default behavior, we get into those sort of problems. But if we do it optionally, there's a little bit more leniency. Peter presents a lot of good data on what we're actually talking about in terms of size. We have block bodies. The header chain will always have to be downloaded and maintained by every client, but just the block bodies is on the order of 100 gigs. Then we have logs that can be deleted as well, and then of course the associated indexes with all of these things take up some space as well. So the sort of requirements of a system like this is that we need to have data retention. We need to ensure that we have data availability in some way. And so we could either say there's a probabilistic availability. Some number of people will always run a non-pruning full node, but it's unsatisfactory solution to just say it's probably fine. So we would like to have some stronger guarantees. That could be doing things like putting the block bodies on IPFS, and then it's discoverable, anyone can download it, it's sort of freely available. We can say that, you know, the Internet Archive parity and the foundation will always pin all of this content, so we have multiple replicas of it. You know, there's methods like that. If we start delving into actually incentivized, like on-chain incentivized methods of ensuring availability, it becomes much more complicated. And so I don't think Peter's proposal does not cover that, and I think that goes sort of beyond what we should be dealing with today, but I'm interested in if people have ideas about that. So obviously, pruning history makes syncing different. Like our parity warp sync right now doesn't rely on history. It actually downloads the snapshot and backfills history. Fast sync is a little bit different, but it would also work well. But a regular sync becomes much more complicated if it's hard to find historic blocks. So basically, we would be crippling regular sync to some extent, but a regular sync takes weeks anyway, so the question is if anyone is actually doing that or not. And I think just covering a little bit of what I hope to get out of today, I think the chain pruning proposal is the least controversial. It's the easiest one to talk about, easiest one to implement. It's something that we can have a very minimal version of like next week if we wanted to, but requires some coordination and agreement between clients. And as it relates to other working groups here, I think it's chain pruning will become important if the other proposals go through and we can actually increase the scale of the chain. Like if we start processing 5 times as many transactions, then a full node will just balloon out of reasonable size. Like it's still to the point where you can buy an SSD to put a full node on. But if we go 10x on the mainnet, then that's not going to be possible very soon. So if the other proposals go through, then this is necessary. If they don't go through, then this is a nice to have. So I'd say the mission is to get to a point during these couple of days where we agree what we should put forth to client implementers as this is what we want to do. And part of the goals of that is sort of establish what problems and concerns exist, especially from like dApp developers and other people who use history in some way, and not just take this perspective of someone trying to run a full node on their laptop. And to figure out a bit of a roadmap. So as I said, the simplest possible solution is something that we can do next week. What is the roadmap to, you know, what other stages of this exists? And I have some ideas here, and sort of map out what are the different stages and when should we be trying to implement them. All right.
Okay, so next on the agenda was a breakout, or actually, did anyone else have presentations? Are we all good?
Any comments about what you said or any new stuff? Because I can do my presentation about state right now if you want to.
That's probably a good idea so people can get an idea of it.
Okay, so you can.
It's Alexi again. Oh, and from now on, if you have any questions from the audience, I'm going to be passing around mics. So just raise your hand if you have a question after. We're not taking questions right now, but just for the future, if we do stuff, we'll do mics because it's kind of hard to hear.
gonna throw me off now. Oh gosh, where is it? Okay. Okay, can you see it now? Right. So before we start going into, so this is going to be about state rent. And before we go into the proposal for the state rent, which I would encourage people to come up with the alternatives to what I was going to present, because it's not, shouldn't just be me writing these proposals. So I would like to present the framework, which is that my attempt to set out the questions which proposal should be able to answer, and sort of the problems that it has to go into, so that when we look at the proposals, we don't have to do a lot of interrogations about what about this, what about that. So and so I start with a list of questions about, like, how do we go from beginning to the actual proposal. And so we're going to go through every question in turn. So, but we'll start with this one. So again, this is my personal perspective, and I would encourage people to come and challenge me on this if they see there's something I've missed here, or something that they disagree with. This is exactly the reason why we're here. I want to hear how this needs to be changed. So I'm claiming that there's two main values that the state is providing to the applications or to people. So first of all, it's the claims. So you can keep some sort of claims on the blockchain, and these claims are automatically available and provable. And essentially, the whole network works really hard on trying to keep your claims available for a very long time. And secondly, that the state in Ethereum allows this kind of synergy between different smart contracts. This is the sort of like a higher level value. And when I was writing the first proposal, I probably more thought about the number one, but I didn't think a lot about number two, because the number one is where the beneficiaries of this value could be the people who are holding the claims, but the number two is not as that clear. So it would be like the users who actually can, for example, trade DAI on a decentralized exchange would be those who sort of benefit from this synergy. So then, why is this? So again, this is my claim, which I need to sort of run through everybody. And so depending on the answers to these questions, we either say, okay, we do need these measures to control the size, or we say, no, we don't need these measures, so there's no actual problem that we're solving. And so the important bit here is that I do depart from so initially, when I read the historical proposals for the state rent, most people were trying to solve the problem of cost of storage, like how much does it cost to buy this 4 terabyte hard drive, how much does it cost to do this and this. I completely ignore this question here, because I think it needs to be solved in a different way, and also it doesn't allow me to constructively discuss this. So I only concentrate on performance impact. And so if we do not constrain the state size, what is going to happen to Ethereum in terms of the performance degradation? And so there's 4 things I'm discussing, is that transaction processing, block sealing, snapshot synchronization, and the snapshot synchronization, but a different aspect. And so I'm trying to figure out what is the function of these performance degradation depending on the size of the state. So number one is when you process a transaction, you very often get the transaction reading the part of the state, and because if the state is stored as a trie or in get and parity, then you would need a logarithmic time in the size of the state to reach the node that you want. And if it's a turbo get, for example, it's probably going to be some sort of linear, but most of the times, because the state is now a bit larger than your usual memory, most of the time the state will be somewhere on a disk. So it will be organized in a database, which normally has some sort of index, which also provides the logarithmic time when you search the entry. So that's why I stayed here. So for most implementation is a square of logarithm time of access. And so you need to multiply this by number of unique items which is accessed. So, and when you think about it, if you believe that this is the function, basically number of uniquely accessed items multiplied by square logarithm of the state size, then you can say, okay, we either constrain the state size or we reduce the number of unique items processed in transactions. Because the other way of solving this problem is just basically say, well, we're just going to make sure that there's fewer transactions going on. Then we don't care, because that's actually linear dependency. So then the next thing is that when you actually seal the block, then you need to recompute. So if you changed anything in the state, then when you come to the seal the block and recompute the state root, you need to actually access some sibling in the Merkle tree of your items, and usually that is 480 bytes from each level, because there's 15 siblings. And again, this is kind of a lot of reasoning, but you can imagine it is still a square logarithm of the state size, but multiplied by number of items modified. But here it looks like the same function, but the actual coefficient is much larger, because it's probably going to be, yeah, so you basically end up reading much more data, because you're not just reading the bit that you're accessing, but you also have to read the siblings in order to redo the Merkle tree. And here people might say, okay, what about caching? So can you just cache things? So yes, you can, but this is actually not explored yet. I think so. When the Ethereum client uses the caching to cache the state, they normally use RLU caching, recently used, LRU anyway. So, but we haven't seen these attacks yet. But essentially, what you can do is that if you know the way that the client's caching things, you can specifically construct transactions which generate cache misses. And if you want to be resistant to these attacks, then you need to, the only caching strategy you can implement is the randomized caching. Essentially, you just hold the random sample of the state, and the sample is going to be slightly different in all the clients, but essentially that leads me to believe that the function is simply logarithmic. So the third number is that so currently the state, I think, with the most compact representation is around maybe 12 gigabytes or something like that. It depends, but I think the most efficient snapshot sync is when you're basically a node joining a network. Instead of reading all the blocks and trying to re-execute them from the genesis, you can do the snapshot sync. This is what most people do these days. So the most effective one is to do a parity warp sync, and that already takes you quite a long time, because depending on your bandwidth, the syncing 12 gigabytes of data it takes a while. And you can probably see that if the bandwidth doesn't grow that much, so then duration of the sync is linear to the size of the state. So you can see this is actually a bigger deal than the previous two, potentially. And then the number 4, which is also very little known, but probably is known to some of the client developers, is that as the state size grows, more nodes start more aggressively prune the state history. So when you are surrounded by the nodes, when your node is surrounded by the nodes who are very aggressively pruning the state history, then it could be that it takes you longer to sync than it takes them to prune away the state you're syncing. For example, you started right now, you start syncing the state which is current now, and then it takes you 2 hours to sync. And in these 2 hours, the chain progressed to 500 blocks or something. And then it could happen that all the peers that you're syncing from already pruned that history, because for them it's too old. So they have nothing to give you anymore. Well, you might have already be halfway through, but the question is that you're going to start from the beginning and try again, or are you going to be patching up the holes? And I think Fred had, and I think Peter also had some proposals to deal with that. And this is where I just recently had an idea. This is where we can involve the simulation group to help us with, essentially to figuring out what is the actual relationship between the syncing, between the pruning threshold and bandwidth and this particular rate of success of the sync. So basically to simulate these failures, sync failures, like how often does the sync fail if you have this bandwidth and this pruning threshold. Yeah, so Fred said that most nodes sometimes can't produce the snapshot in time because it just yeah, so they hit the pruning threshold before they can actually produce this warp sync snapshot. Hmm?
It takes on a decent machine about 4 hours to generate a snapshot. And because of the combination of factors? No, just iterating through the database takes that long. So just like I/O. Yeah.
Okay, so these 4 things that I've described is the real reasons why I think we need to manage the state size. And I think this is up to discussion, but I would like to not talk about cost of storage, because this is very distracting conversation and it needs to be solved in a different way. And so here, before we start going to solution, maybe we can mitigate this problem somehow without too radical things. Maybe we shouldn't just do rent, but so we could do a little bit of mitigation. And if you know about other mitigations, please let me know, because we can add them to the list. So my 2 mitigations I could think of is that we could improve the latency of block processing by sort of pre-warming the caches. So we can look at for example, we could look at the transaction pool, or we get the miners to pre-announce the blocks, and we can figure out, like, with a certain probability, like what part of the state these transactions are going to hit. And so we can pre-warm them in the caches, right? So by the time the block comes, we already have the warm cache, and then it will reduce some of this latency. But important to note, it does improve the latency, but not the throughput. Because if you're looking for, because you can basically, so if you're hitting the point where processing the block takes almost as much as the block propagation, inter-block time, then this is not going to help you. So we're still hitting the limit. So if processing of blocks takes longer and longer, for example, now if it takes 500 milliseconds or 400 milliseconds, and if we keep the state growing, it will then take 1 second, it will take 1.5 seconds, and then we know that the block time is only 15 seconds, so we probably have to increase the block time or something like that if we don't want to, hit some problems. So even if you do this latency mitigation, it's not going to solve the problem of throughput. And another thing we can do, this is where we've been talking to Fred about, to make some sort of clever syncing algorithms which allow you to improve the success rate for the sync and things like this. So, am I for 10 minutes? Okay, so I'm going to try to go faster from here. So how could we manage the state? So here, so you're probably familiar with this stuff. I just took it from a book about feedback control system. So there's this forward control and there's this feedback control. You're probably familiar with this. Think about thermostat is a feedback control. So if you think about EVM, then the gas schedule is the feed-forward control. So we're figuring out how much each instruction should cost, and that should allow us to limit the number of computations which the nodes will make. An obvious example of the feedback control is the miner difficulties, so which can change after each block. so here there's a choice. So in any proposal, we can either try to do the feedback control, or we can try to do the feed-forward control. So if we want to do the feedback control, which then we need to have a state size observable within the protocol, and then somehow change the parameters to make sure that we are within the bounds. And if we want to use a feed-forward control, we're just like using some sort of benchmarking. Yeah, using some benchmarking, for example, with the help of our simulation group, just figure out, okay, what are the, like, let's say we want to fix the rent or fix other things, or just do some simulations. Okay, this sounds like a good value, and just put it in and hope for the best. Hope that this is going to work. Or maybe later on we can change it via hard fork. So let me just stop there. I don't want to. I think this is enough granularity for this particular presentation. We're gonna walk you through this very quickly to show you the other questions that we want to answer, and maybe we could address the other bits in a different presentation. So first of all, so if we think about both feedback control or feed-forward control, so what we need to think about is that what is our input and what is our output? What do we want to regulate? In our case, do we want to regulate the actual state size, or do we want to regulate the rate of growth? So they could come up with two different mechanisms. And then we also need to define whether those metrics have to be on state, in the state itself, or out of the state. And obviously, if we do the feed-forward control, they don't have to be in the state, because we just come up with some values. If we want to do feedback control, they have to be in the state, because we need to be able to verify that the control is executed correctly, because most of the clients now sync with a snapshot without history, so they need to be able to, using only the data inside the state, to verify that the control has been applied correctly. So then another thing we need to think about, what are we going to change to do our control? And in this case, we know that there are like 6 different operations which can increase the state or decrease the state size, and probably we want to somehow affect those operations. And then I also suggest that we can do 3 different things. We can increase the cost of those actions, the ones that increase the state. We can make the actions which decrease the state more rewarding, or we can directly reduce the state size, which is what state rent is doing. So there's like 3 approaches which could be combined. And so one of the obvious thing to increase the cost of the actions is do some sort of increase the gas cost of the, let's say, of a store or something like that. Let's say from 20,000 to 40,000. And so it has 2 effects. What I'd say is, first is scarcity, and another one is cost. By scarcity, I mean is if we don't change the block size, gas limit, but simply increase the store's cost, then means that there could be theoretically fewer stores that you can do in a block, which will already reduce the theoretical maximum expansion from this operation. And the second intended effect of this is to make it harder or less appealing for the people to actually do these operations, because it costs more. But I would say that the second effect might actually be somehow circumvented by some private agreement with the miners or with the mining pools, because because in this sort of economic transaction, there's only 2 parties, the transaction sender and the miner, so they can do some sort of agreement, and they can even make it appear that they don't have an agreement by doing some sort of kickbacks or rebates. And the open question is that, do we think that the first effect is enough so that we can kind of ignore the fact that people can circumvent the second effect? Maybe it is. Another thing I want to talk about is about the gas refund. So at the moment, the one idea to reward the state decreasing actions is do gas refund. Unfortunately, this mechanism is fraught with some drawbacks, because there is a cap that you cannot get more refunded than half of the gas that you already spent, which kind of makes it a bit tricky to actually use the refund. So if you have a transaction that doesn't really spend anything but does a lot of clearing, then all the refund is unfortunately lost, because it will be less, it will be much more than the half of the spent. And there are reasons why this cap was introduced, but we potentially can come up with a solution to make this reward much more straightforward and effective. So yeah, I'm not going to talk about the lockups right now, because it's in detail described in second proposals, but this is one of the mechanisms to make the refunds simpler. If you require everybody to lock up some Ether when they expand the state, then you can actually return that almost in full, or in full when you clear a state, and that refund should come not from the miners but from the protocol itself, and that it means that you don't have to have a cap. Yeah, so and then this third way is to directly reduce the state size, which is the rent. And so there's decisions you need to make about what we're going to evict and when we're going to evict this. And yeah, intuitively, it's like we need to just evict something that nobody cares about, some old stuff. And there's also different ways of doing it, which I'm talking about here, but I think I'm going to cut it short. So yeah, and this is the important point that I think any proposal should explore about. If you introduce any control, you need to think about whether the system can actually try to evade this control. Like where sometimes, like I talk a lot about the hoarding problem. Is that when you increase the cost of some action, and then you have to announce it in advance, then people can try to sort of prepare for that by hoarding some of the state and then reselling it or just keeping it for themselves. So another other example of how the system can try to evade the control is basically this private agreement with the miners to try to avoid the increasing of the cost. So that's it for this. But again, to repeat for what I said before, this is not actually finished. So this is just an attempt to come up with these set of questions and things that every proposal has to look at least, and explain what they do about it, and does this problem exist and stuff like this, so that we can have proposals from pretty much anybody they want, but every one of them have to have these sort of questions answered, so we don't have to spend the time of pulling this information out. So then we can just put the proposals next to each other and we can compare them like based on this criteria. And if somebody knows about more things to look at, please let me know. That's it.
Thanks so much, Alexei.
I think maybe it's enough presentations, or is anybody else wants one?
Anyone want to jump up there? Oh yeah, you want to go out? Amir?
Oh no, sorry, I was waving.
You were waving to someone.
We probably have another time for another one. Then it will be in 1 hour presentation.
Yeah, so you're saying breakouts, or?
Well, the last presentation or breakout?
I don't think there's any more presentations. Okay, great. So should we do a thing everyone gets in like a corner with the chairs or something?
I was actually thinking about the chairs. They invite people to sit down, and then it sort of kind of looks a bit rude to just, if you stop talking about things, you want to go somewhere else because there's more interesting discussion there. I want to encourage people to just drift around. So maybe we either agree that just standing up and going away is not considered to be rude, or just stop the conversation, going somewhere else, or we should be standing in corners instead of sitting.
Cool. First thing, can we stop the live stream? Thank you. Okay.